this lesson, we're going to discuss the very basics of how Exchange databases and logs work. Now, this can actually be a very complex topic. There is a lot of information out there that's published that goes into great depth in explaining exactly how Exchange databases work, how transaction logging works, and all the other intricate details surrounding the topic. I'll add some links below this video to other resources such as books and TechNet articles that you can go ahead and read if you absolutely want to know everything about this topic. But what we're doing here in this video is covering just the minimum that you would need to understand for the purposes of database backup and recovery. So the way I explain how the database works in Exchange Server 2013 and previous versions of Exchange Server is that it's all about when things happen. Now, those things could be items being added, items being modified, items being deleted. And those items could be mail items, calendar items, contact items, any of those types of items. So those sort of things such as add, modify and delete operations happen first in memory on the server, and they're also written to a transaction log file stream. And by file stream, what I basically mean is a number of files, 10, 100, 1,000, depending on how much actual activity is going on in the server. And all of those individual files make up one transaction log file stream for that database. And there is one transaction log file stream per database on the server. Now, sometimes when people hear that explanation, they think, well, what about the database file itself? When do the changes happen within the database file itself? And if all of this stuff is going on in memory, is that the best way for things to happen? Consider that operations such as adds, moves or modifiers and deletes happening in memory can happen a lot faster than if they were constantly happening within the database file itself. Simply put, memory can operate much faster than a file on a disk, and all that constant I/O basically being limited by the speed of that disk subsystem. And this is one of the reasons why Exchange servers, particularly mailbox servers, tend to consume almost all of the available memory on the server. Now, some people get quite alarmed when they see that. They think that their Exchange server is not performing well when they see that the memory utilization is in the 90 to 95% range. But of course, when you consider that things are happening in memory and they're able to happen in memory faster than if they were happening on disk, it makes sense for Exchange to use the memory that is available to speed up operations and use it to its maximum capacity. Now, what about all that stuff in memory? Is it at risk of being lost if there's a problem with the server? Well, Exchange actually has fairly sophisticated memory management of its own, and it periodically writes changes that are being recorded in memory or occurring in memory to the database itself. So you consider that things have happened in memory. Those things have also been written to a transaction log, and then from time to time they're also committed to the database itself. And those database commits tend to be a lower priority task to keep the system running as well as it can. Now, each time a number of transactions are written to the database file, a checkpoint is updated so that the server knows which log records have been written to the database. So as you can see in the diagram, let's say for example there's 4 transaction logs worth of things that have happened, and the first 2 log files worth of transactions are committed to the database. And the checkpoint is moved along so the server basically knows where it's up to as far as stuff in memory and stuff in the logs being committed safely into that database file. That also means that under normal conditions there will be things or changes that have happened in memory and they've been recorded in logs, but they have not yet been committed from memory to the database. Now, that's fine during a controlled or a deliberate database shutdown, because of all that stuff in memory is flushed to the database and a clean shutdown takes place. But when we're talking about the topics of backup and recovery, we need to consider what sort of failure scenarios might impact the server and how the way Exchange databases work help us to recover from those failure scenarios. So let's consider the first recovery scenario, power loss on the server. So the server has had an unexpected power loss, it's restarted, And because the database was not able to cleanly shut down, there were transactions in memory that had not been committed to the database. However, those transactions had been written to the transaction log files. And because the database, when it's starting up, is able to tell from the checkpoint which logs contain transactions that have already been committed to the database and which logs don't, it is able to replay those necessary logs into the database and bring it up to date with the information that was lost from memory when the server shut down before it could be flushed into the database. So put simply, if the server has an unexpected restart, the database should be able to recover with no data loss. Let's consider another recovery scenario where the log files themselves are lost. So let's say, for example, that the hard drive that the logs are located on suddenly crashes or fails, and access to those logs becomes unavailable. The Exchange server should detect that it's no longer able to write to its transaction log files, and it should dismount or shut down that database, flushing the information from memory to the database in that process. So it should still be able to do a clean shutdown of the database. So you'll then go ahead and replace your log drive because the database won't start up without that log folder path being available. And the database is able to mount, start a new transaction log stream, and operations will continue with no data loss. Before we look at the next recovery scenario, let's talk about database backups for Exchange servers. Now what a backup does is it effectively draws a line in the sand and says, at this point in time, I've taken a snapshot of my database file and all of the necessary transaction logs up to that checkpoint, and I've backed them up into my backup destination. Now when that process completes, it's able to say, I no longer need those transaction logs from before that checkpoint, and so those log files are removed from the server or truncated. And that's one of the reasons, apart from protecting our data, that we would run a database backup. If you're running out of space on your log volume, you've probably heard that people would recommend that you run a backup to truncate the log files. Well, this is why that truncation occurs. So if we've taken a backup of our database, let's look at the recovery scenario where a database is lost. So something has happened to our database file. The disk drive that it sits on has failed or become corrupt, or the database itself has become corrupt. It's basically unusable and it won't mount, and we need to do something about it. We have a last backup available, hopefully, and we also have all of our current transaction log files available because they're on a separate hard drive that was not affected by the failure. So in effect, what we have is a copy of the database from a point in time and a log record of all the changes that have happened to that database since that point in time. Now hopefully you can see where I'm going with this. The database backup is restored, and Exchange then begins its recovery process. All of the log files since that point in time that are still intact on the server are replayed into the database to bring it back up to the point in time where it became corrupt or unavailable, or basically where the data was lost. So the end result is that the database is back online with little to no data loss, and that of course is one of the reasons that we back up our databases. And it's also one of the reasons where it's recommended to keep your database files and your log files on separate volumes that are isolated from each other in terms of failures such as hardware failures. So what happens in the recovery scenario where both the database and the logs are lost? Well, if all you've got is your last backup of the database, so you've got the copy of the database at that point in time, and you no longer have that log record of all the changes that have happened since, then effectively all those changes are lost. But as you can see, this is why we separate logs and databases onto different disks, so that a single failure of a hard drive couldn't wipe out both our logs and our database in one go. So each of those scenarios I've just talked about are mostly relevant in the context of a single mailbox server. And you might be thinking, what about DAGs, or what about database availability groups? Now, DAGs are the high availability and fault tolerance for the mailbox server role in Exchange Server 2013 and also in Exchange Server 2010. And basically what it involves is databases that replicate copies between anywhere from 2 to 16 DAG members. Now this can reduce or even remove the need to ever restore from backup in a lot of scenarios. If you had a failure of a single database copy, then in theory, one of your other DAG members has a healthy copy of the database that it can come online and continue serving mailbox data to your users. Now we're going to look at DAGs a lot more in a later module on high availability. Just keep in mind that for now, these backup and recovery scenarios mostly relate to single server situations, but it is useful information to know and understand for DAGs as well. Now hopefully that's given you some idea of how the Exchange database engine works, in particular how it relates to backup and recovery. If you're still a bit uncertain about that information, don't worry, because what we're going to do is walk through each of those recovery scenarios using our test lab environment and demonstrate exactly what happens and how you can recover from those failure scenarios. And I guarantee you that once you actually see it in action yourself, it starts to make a lot more sense. So let's move on to the first demonstration.